Evaluate logarithms, an important question with simple strategy. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken a very important logarithmic expression to simplify. It can be a challenge question for many. The question here is to evaluate 4 over log to the base 10 of 5 minus 2 over log to the base 4 of 5. You can pause the video, answer the question, and then look into my suggestions. Well, to evaluate this expression, we need to understand logarithmic rules. One of them is change of base. So let me just remind you of change of base formula. So if I have logarithmic expression as log to the base of a of b, I could always change the base to anything, right? So I could change it to c. So in that case, it would be log to the base c of b divided by log to the base c of a, correct? So this is the change of base formula, which is being used normally. Now, the trick part here is to understand what happens if I change the base to b, right? So look at that part. So here is a variation, right? So here is a variation, which is an important twist, right? So let's rewrite this particular expression, log to the base a of b. And now instead of c, I want to change it to b itself. Then what happens? Log to the base b of b over log to the base b of a, right? And you can see log to the base b of b is 1, right? And therefore, I could rewrite this as 1 over log to the base b of a. Do you understand this part? So effectively, we have written log to the base a of b as 1 over log to the base b of a. Do you see that part? So this is a hint for you to solve this particular question. Log in the denominators will also remind you of switching their arguments. You get the idea. And then you can rewrite the question and solve very easily. Perfect. So I hope with this explanation, you can now solve this question. Perfect. So try it out and then check with my solution. So let's move forward in solving this particular question. So we'll use this identity, which is writing them as a reciprocal. So basically, let me rewrite this expression now. So we have 4 over log to the base 10 of 5 minus 2 over log to the base 4 of 5, right? So I can rewrite this as 4 times log to the base of what? Swap it, right? 5 of 10. Do you see that? Minus 2 times log to the base 5 of 4. Now by doing so, what have we done? We have these logs with the same base, and now we can apply all the properties of logarithms which we learned with their same base, correct? Okay, so this goes to the power of 10, so I could rewrite this as equal to log to the base 5, 10 to the power of 4, right? Minus log to the base 5, 4 square. Right? And now we can apply the second property, which is writing them as quotients, right? So we have 10 to the power of 4 divided by 4 square, right? Now can you simplify this? 10 to the power of 4. Well, 10 is 2 times 5, right? So let's rewrite this. We could write this as log to the base 5. 2 to the power of 4 times 5 to the power of 4, because 10 is 2 times 5, right? And here we have 4 square, right? 4 square means 2 square square, right? You get the idea. So what we did was that we wrote 10 as equals to 2 times 5, right? And we wrote 4 as 2 square. And therefore, we got this particular thing, correct? See now, 2 square and this cancel, right? This is 2 to the power of 4, that is also 2 to the power of 4. And we are left with log to the base 5, 5 to the power of 4. And that is 4, correct? Or you could write 4 log to the base 5 of 5 and then the answer 4. So we get this as equal to 4. Perfect. So that is how we could actually simplify this and write as a reciprocal. So it's kind of important to understand how do we work with logarithmic properties. And this particular property shown here is very, very important to solve such questions as given to you just now. I hope it makes sense. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the address given. Perfect. Thank you for your time and all the best.